So in my previous lecture, I discussed about numerical integration. There we discussed about the numerical, the Newton codes general formula. We considered the Newton's forward difference interpolation formula, and we integrated it with respect to x in the interval x naught to xn. We took x naught as a, xn as b. We divided ab into n number of equal parts. Then we used the Newton's forward difference formula. So it gave a general value of integration formula, a general integration formula. So for different values of n, we get different set of rules. So accordingly, for n is equal to 2, we get the Simpson's 1/3 rule. So it reads as x naught to xn fx dx. Here n is even number because n is 2 even number. So h by 3 times. That's why the name Simpson's 1/3 rule. H by 3, where h is the common difference or the length of the interval. Or if I divide the interval into say even number of equal parts, that length of that each part, that is h. So h by 3 times the first term and the last term y0 plus yn plus 4 times the odd terms y1 plus y3 plus sum of odd terms y1 plus y3 plus y5 plus so on, plus 2 times the sum of even terms y2 plus y4 plus y6 plus so on. So this is the Simpson's 1/3 rule. So n should be even number, and we are dividing x naught to xn into n number of equal parts or even number of equal parts. Then I consider the second formula which we have studied. It is Simpson's 3/8 rule. Right. There I considered n is equal to 3. That is, we divided the interval AB into multiple of 3 parts. That is either 3 or 6 or 9 or 12 like that. So we divided interval AB into multiple of 3 number of parts. Right. So there x naught to xn f of x dx is given by 3h by 8. That's why the name 3/8 rule. So the rule is y0 plus yn, the first term plus the last term, plus it is 3 times, it is y1 plus y2 plus y3 is not there, y4 plus y5 plus y6 is not there, plus so on. That is y7 plus so on. What I did is 3 times sum of non-multiple of 3 terms. I write this as sum of non-multiple of 3. Here see, y1, y2 is there. 3 is multiple of 3, so y3 is not there. y4 plus y5. y6 is multiple of 3, so I don't consider that. So y6 is not there. Then y7 plus y8. The next term y9, it will not be there. Plus it is 2 times multiple of 3, y3 plus y6 plus y9 plus so on. So this is the Simpson's 3/8 rule. So multiple of 3, right? 3 terms. Sum of multiple of 3 terms. So y3 plus y6 plus y7, y9 plus so on. So this is Simpson's 3/8 rule. So n should be multiple of 3. That is the condition. Multiple of 3. Right. Then the third one is Wedel's rule. Wedel's rule. Here I consider n to be 6. I take n to be 6 in Newton codes formula. So that gives me the Wedel's rule. So it reads as, right, integration. So what I should do? I should divide the interval into multiple of 6 parts, either 6 or 12 or 24, etc. Or 18 or 24, etc. So I consider x naught to xn, or initially I divide the interval into 6 parts. So x naught to x6 fx dx is equal to 3h by 10 into y1 plus it is 5y2 plus y3 plus I'll I'll just confirm. So I'm sorry. It is 3h by 10. It is sorry y naught plus 5 times y1 plus 5 times y1 plus y2 plus 6 times y3 plus y4 plus 5 times y5 plus y6. So this is the case when I divide the interval into 6 number of parts. Suppose if I add x naught to x12, if I divide f of x, ab into 12 equal parts, then this will be f of x dx is equal to 3h by 10 into y naught plus 5 times y1 plus y2 plus 6 times y3 plus y4 plus 5 times y5 plus it is y6. Then again it starts with y6. So it will be 2 times y6 plus 5 times y7 plus y8 plus 6 times y9. That is what you have to do. You add 6 to this. Y not plus it starts with, see, it ends with y6 here. Then you start adding 6 to these terms. Say y not plus 6. So y6 it is. Y not, y times 0 plus 6, y6. So this y6 plus the other y6, it becomes 2y6. Then 5 times y1 plus 6. So y7 plus y2 plus 6, y8 plus 6 times y3 plus 6, y9 plus y10 plus 5 times y11. I added 5 to here plus y6 plus 6, so y12. So this is how you have to remember the formula, right? So this is Wedel's rule. So what you have to do? Divide the interval into multiple of 6 parts. Multiple of 6 equal parts. So this is the Wedel's rule. This we have discussed in the previous class. So I don't go much into the details. So now I directly go to the problems. So the question says evaluate the integral. I consider the integral now. Evaluate the integral into it was the question number 12. So the question number 12 what it says is evaluate. There is question number 12. Evaluate integral 0 to pi by 2 under root sine x dx using Simpson's one-third rule, taking 10 equal parts, taking 10 equal parts, right? So this is the question, right? Now I have to solve this problem. Right now I consider first I divide 0 to pi by 2 into 10 equal parts, right? Because as I told you, it should be always for Simpson's one-third rule, it should be even number of equal parts, so 10 equal parts. That means I should go up to x0, x1, x2, up to x10, right? So now find out first h. So h will be what? It is x0 xn minus x0 divided by, here 10 equal parts is asked, so it is xn minus x0 by 10. So that is equal to pi by 2 minus 0 by 10. That means it is pi by 20. Pi by 2 into 1 by 10. So it is pi by 20. Now, so I start writing the table now. So x is equal to, then the value of the function fx is equal to. So here I have to have 10 values. So it starts with 0, right? Now it starts with 0. So you have to first form the table. It starts with 0. What is sine 0? Sine 0 is 0. Root of sine 0 is 0. So this is x0. This is y0. Then it is x1. X1 is what? 0 plus pi by 20. So pi by 20. So it is under root sine x. Under root sine pi by 20 is 0.3955. 0.3955. Then it is pi by 20, I have to add. It is 2 pi by 20. So it becomes easier for you. You maintain this. I can write this as 1 by pi by 10 I can write, but you just add pi by 20, keep on adding. So 2 pi by 20, that is y2. So this will be what? Under root sine of 2 pi by 20 will be 0.559. Then 3 pi by 20. That is my y4, y0, y1, y2, y3. So 3 pi by 20 will be equal to 0.6738. 0.6738. Always you have to bear in mind that you have to keep your calculator in radian mode. That you have to always remember. Then 4 pi by 20. 4 pi by 20 is same as pi by 5. So 4 pi by 20. So that is pi by 5, y4. So that is 7667, 0.7667. Then 5 pi by 20. So I came to the center point. 5 pi by 20, that is pi by 4. So that is equal to 0.8409. 0.8409. Right, then 6 pi by 20. So that will be 6 pi by 20 is 0.6738. 0.6738. Then 7 pi by 20. So that will be equal to 0.9439. 0.9439. Then 8 pi by 20. So that will be equal to 8 pi by 20 is 0.9752. 0.9752. Then 9 pi by 20. So 9 pi by 20 is 0.9938. 0.9938. Then 10 pi by 20, that is nothing but pi by 2. So sine pi by 2 is 1, square root of 1 is 1, so the answer is 1. So this is my y0, this is y1, this is y2, this is y3, this is y4, this is y5, y6, y7, y8, y9, y10. So I have divided the interval into n equal parts. So my step is what? I should find out h. Then I should I should form this table. Then my next rule is what? Now x naught to x10 f of x dx will be equal to what? H by 3 into, it is first term plus the last term, y naught plus y10 plus 4 times the odd terms. So it is y1 plus y3 plus y5 plus y7 plus y9, because y10, y11 and all are not there because I have divided the interval into n number of parts, plus twice the even terms. So how many even terms will be there? Y2 plus y4 plus y6 plus y8. Right? Y10 is the last term I have added here. So y10 will not be there. So if I simplify this, h is what? It is pi by 20. So pi by 20 into 3 times all these things, y0 plus y10 plus 4 times, it is y1 plus y3 plus y5 plus y7 plus y9 plus 2 times, it is y2 plus y4 plus y6 plus y8. So if I substitute these values from the table, so I get this as pi by 60 times. If I simplify this, it is 20.3348, or I can write this as 0.3389 times pi. If I substitute the value of pi, I get this to be 1.1694. 1694. So this is the answer for 0 to pi by 2 root of sin x dx. This is the question number 12. Then the question number 13. If I go to question number 13, what it says is find the question number 13 is using Verdon's rule. Using Verdon's rule, find integration from 0 to 1 x over 1 plus x squared dx. Right. So here, and what he says is by taking 7 ordinates, by taking 7 ordinates. 7 ordinates means you start from x naught. X naught is first one, x1, x2, x3, x4, x5, x6. So x naught to x6, that is x naught, x1, x2, x3, x4, x5, x6. So this gives me 1, 2, 3, 4, 5, 6, 7. So 7 ordinates are there. So now what is my next step? That means what he has clearly said, you are required to divide the function into 6 number of equal parts. That is, I should divide. Therefore, h will be what? It is xn minus x naught by 6, or this is 1 minus 0 by 6, or this is 1 by 6. So my x0 is 0, x1 is 1 by 6, x2 is 2 by 6. It is like that. So now what is my next step? I should form the table first. So I form the table now. So for mine, this one, so x, and my f of x is what? F of x is x over 1 plus x squared. I should divide into 6 number of equal parts, right? So I should divide into 6 number of equal parts. So x naught is 0. So y value will be, f of x also will be 0. It is 0 by 1 plus 0. So y naught value is 0, right? Then y1 value. Y1 value will be, so x1, this is this one, though x1 is 1 by 6, right? So y1 is 0.16216, 0.16216, right? Then I should find out 2 by 6. So it is 2 by 6. So that will be equal to 0.3. So this gives me y2. Then 3 by 6. So that means it is actually 1 by 2. So it will be 0.4. Then 4 by 6. So it will be 4 by 6 means it is 2 by 3. 0.46154. 0.46154. Then 5 by 6. So it will be 0.4918. 0.4918. Then 6 by 6, that is 1. So the answer is 0.5. Right? So I got the value. So this is y0, this is y1, this is y2, y3, y4, y5, y6. Right? Now my second part is over. Right? My first step is over. First I should find out h. Then I should divide AB into the required number of parts. Then I should find out the function, value of the function at those x's. Then I should use the Wedel's rule. So Wedel's rule, what it gives? So what it says, x0 to x6 I should use, because I have divided the interval into 6 equal parts. So fx dx will be what? 3h by 10, right? What is the value of h? H is 1 by 6. So 3h by 10 into y0 plus, it is y0 plus, I forgot, y0 plus, right, y0 plus 5 times y1, correct now? 5 times 5 times y1 plus y2 plus 6 times y3 plus y4 plus 5 times y5 plus y6. So this is my 3h by 10. So this will be equal to what? 3 times h is what? 1 by 6 divided by 10 into y0 is 0 plus 5 times y1 is 0.16216 plus y2 is 0.3 plus 6 times y3. So 6 times y3 is 6 into 0.4 plus 5 y4. Y4 is 0.4615 0.46154 plus 5 times Wi-Fi. 5 into Wi-Fi 0.4918 plus 1 0.5, right? If you simplify this, so it is 3 1 the 3 2 the, so 1 by 2 into 10, so it is 1 by 20 into this one 0 plus 0.5 plus 5 into 0.16216 plus 0.3 plus 6 into 0.4 plus 0.46154 plus 5 times 0.4918. So this gives me the final solution as, so this gives me the final solution as 0.6930.0.693. 0.34661. 0.34661. So this is how we use the Weddell's rule to evaluate the integrals, right? Now I consider one more example using Simpson's 3/8 rule. I have not used Simpson's 3/8 rule now. So I consider the 14th example. The 14th example says use Simpson's, again it is one third rule to evaluate integration 2 to 8, right? Integration 2 to 8 dx over log of x to the base 10, right? So now you have to evaluate this 2 to 8. So since what I will do is, again with 7 ordinates, use 7 ordinates. That means what? I should divide this into 6 equal parts. Solution. So 7 ordinates implies divide into 6 equal parts, right? Therefore, what is h now? So h will be equal to xn minus x naught by n. So that is equal to 8 minus 2 by 6. So h is 1, right? So h is 1, correct now? H is 1. Now I have to form the table now. First I got this one. Now I have to form the table. So I write it in the next sheet. So that will be. So that will be equal to that is. What I will do now, x is 1, I start from 2. X, then I write 1 by log of x, 1 by log of x to the base 10. So I find out those values now, right? X starts from 2, it goes up to 8, h is 1. So 1. When x is 2, what is the value of y? When x is 3, what is the value of fx? When x is 4, what is the value of fx? When x is 5, what is the value of fx? 6, what is the value? 7, what is the value? Then 8. Right, now I form the table. So my table will be 3.3219, 3.3219, right? Then 2.0959, 2.0959, then 1.6610, then 1.4308, then 1.2851, then 1.1833, then 1.1073, 1.1073. So this is my y0, this is my y1, this is y2, this is y3, this is y4, this is y5, this is y6. So now I have to use Simpson's one-third rule. So by Simpson's one-third rule, what we have? Integration 2 to 8 dx over log of x to the base 10 will be equal to h by 3. H is 1. We have already calculated the first term plus the last term, y6, plus 4 times the odd terms. 4 times the odd terms are y1 plus y3 plus y5. Right. Y6 we have already, Y7 is not there. Plus 2 times the even terms excluding the last term. So it is 2 times Y2 plus Y4. That's all, only 2 even terms. So if I simplify that, so 1 by 3 times, if I simplify that, it is 1 by 3 times. If I substitute these values, I get 26.1614, or the final answer is 9.705. It is 9.705. You just verify this. So this is the, you just find out. Because it is 26.164 means it can't be 9. It can be 8. So 3 is 24, 21 means 7. Yeah, it is 8.7205. Just verify this. It is 1 by 3 times 26.14 because h is 1. Right? So this is the problem number 14. Now I come to the last problem, problem number 15, which makes use of Simpson's 3/8 rule. Right? Simpson's 3/8 rule in the question bank. So what it says is use Simpson's 3/8 rule to find integration 0 to 0.6 e power minus x squared dx by taking 6 sub intervals. That means again, he is asking you to divide the intervals into 6 parts. So this is your function. E raised to minus x squared is your function, right? Now I find out the values now. So solution. My first step is what? I should find out h. H is what? Xn minus x naught by 6, because n is 6, he has asked for 6. So it is 0.6 minus 0 by 6. That means h is 0.1. Right. Then what is my next step? I should find out x and corresponding values of y. I should find out x and corresponding values of y. So it is y is what is f of x, that is e power minus x square. So I find out that. So it starts from 0. So when x is 0, definitely e raised to 0 is 1. When x is 0.1, then when x is 0.2, then when x is 0.3, then when x is 0.4, then when x is 0.5, then when x is 0.6. So now I have to find out the values, right? I have to find out the values. So the values are, see, y1 for 0.1 it is 0.9905. You can evaluate. So it is 0.9905. For x is equal to 0.2, the value is 0.9608. Then for x is equal to 0.3, the value is 0.9139. For x is equal to 0.4, the value is 0.8521. Then x is equal to 0.5, the value is 0.7788, and x is equal to 6, that is 0.6, the value of y is 0.6977. Right. So now my table is also over. Next is what I should use? Simpson's 3a through 3a rule. What it says, integration from 0 to 0.6 e power minus x squared dx will be what? It is 3h by 8 into first term y0 plus the last term y6 plus it is 3 times, right? 3 times the non-multiple of 3 terms, sum of non-multiple of 3, that is y1 plus y2, y3 is not there, plus y4 plus y5. See, I do not consider higher terms because the value ends at y6. So y6 is my last term. So y7 and all are not there. So 3 times y1 plus y2 plus y4 plus y5 plus 2 times the multiple of 3 terms. So it is here only one term is there, that is y3, because y6 becomes the last term. Right, so 2 times y3. So if I use this, if I simplify this, I get 0.3 by 8 because h is 0.1 into my value will be 14.2721, or the final answer is 0.5352. So this is my Simpson's, that is, this is my integration of 0 to 0.6 e power minus x squared dx. So the answer is 0.5352. So this is Simpson's 3/8 rule. So this completes, I have solved almost all the problems of the module 5. Now, in module 4, we have to consider the Cauchy's root test. You solve all the problems of Cauchy's root test as well as D'Alembert's ratio test. Then you consider the proof of j half x and j minus half x in Bessel functions, and the expressing a given polynomial in terms of p0, p1, p2, etc. That we shall do it in my next lecture, right? So have a nice time, study well. Thank you.